Hi, I'm Kyle Camphausen, and today I'll be going over problem 76 from Chapter 20, Radioactivity. This problem asks, suppose a patient is given 1.55 micrograms of iodine-131, a beta emitter, with a half-life of 8.0 days. Assuming that none of the I-131 is eliminated from the person's body in the first 4 hours of treatment, what is the exposure in Curie during these first 4 hours? Exposure is the number of decay events to which a person is exposed. So, basically, how many decay events in Curie will the patient experience over the first 4 hours after treatment with the radioisotope? First of all, we need to define the value of 1 Curie, which is 3.7 times 10 to the 10th decay events per second. Now, what we're given are the mass of iodine-131 in micrograms, which is 1.55 micrograms. We also know that our half-life is 8 days and that we're calculating the exposure in Curie over a time period of 4 hours. We're going to be using the integrated rate law in order to find the amount of decay that occurs over a 4-hour period. For the integrated rate law, N0 is the amount of substance we start with, NT is the amount of substance we have left after 4 hours, K is our rate constant, and T is our time, which will be 4 hours. To find K, since all decays follow first-order kinetics, we can actually use the first-order half-life equation from Chapter 14, which is half-life equals 0.693 over K. Since we already have our half-life of 8 days, we can just plug it into the equation to find our K value of 8.6625 times 10 to the negative 2 days to the negative 1. Now that we have K, we can plug in our variables into the integrated rate law. We must remember to make sure that our units of K and T will cancel. Thus, it is necessary to convert T, which is 4 hours, into days in order to complete the calculation. We can use our natural log laws, in which log division becomes subtraction, to solve for our answer of 1.5278 micrograms of iodine-131. This value is how much of the isotope is left over at the end. To find the amount that decayed, we need to subtract this from our original value of 1.55 micrograms to find an answer of 0.0222 micrograms of iodine-131 that decayed. Now, to find the amount of decays the patient experienced, we know that for every mole of iodine that decays, there is 1 mole of beta decays. So, we can simply use the molar mass of iodine-131 in order to solve for the amount of beta decays that occur with an initial mass of 0.0222 micrograms of iodine-131. We come to an answer of 1.02 times 10 to the 14th decays. Now we know the amount of decays over 4 hours. We simply need to convert it to decays per second so we can solve for Curie. We know that there are 3,600 seconds in an hour, so we can use dimensional analysis to solve for our answer of beta decays per second, which comes out to 7.08 times 10 to the 9th. Finally, to convert to Curie, because we already have the same units, we just need to divide our decay rate that we solved for by the value of 1 Curie, which is 3.7 times 10 to the 10th decays per second. We find a value of 1.91 Curie for the decay of iodine-131 over a 4-hour time period. Thank you for watching.